Yes, the described configuration violates National Electrical Code Section 230.7. National Electrical Code Section 230.7 states that service conductors shall not be installed in the same raceway or cable with feeder conductors. In the scenario presented, the feeder conductors from the service disconnects are routed back into the auxiliary gutter, which is also carrying the service lateral conductors. This is a direct violation of 230.7. To further elaborate on why this is a violation, it is important to understand the definitions of service conductors and feeder conductors. Service conductors are the conductors from the service point to the service disconnecting means. The service point is the point of connection between the serving utility and the premises wiring. Feeder conductors are all circuit conductors between the service equipment, the source of a separately derived system or other power supply source, and the final branch circuit overcurrent device. The auxiliary gutter in this scenario is acting as an extension of the service conductors from the service lateral to the service disconnect. Because the feeder conductors from the disconnects are routed back into the gutter, they are intermingled with the service conductors in the gutter. This configuration presents several potential hazards. Firstly, it can create confusion during maintenance or troubleshooting. Identifying which conductors are service conductors and which are feeder conductors becomes difficult, potentially leading to incorrect procedures and increased risk of electrical shock. Secondly, the mixing of service and feeder conductors in the same enclosure can increase the risk of insulation damage. Service conductors are typically ungrounded conductors and carry the full fault current available from the utility. If a fault occurs on a service conductor, the resultant high current can damage the insulation of the adjacent feeder conductors, potentially causing a short circuit or ground fault. Thirdly, the National Electrical Code aims to isolate service conductors from other parts of the electrical system as much as possible to prevent faults on the load side from affecting the service. Routing feeder conductors back into the service equipment enclosure compromises this isolation and increases the risk of a fault on the feeder side propagating to the service conductors. To correct this violation, the feeder conductors must be routed separately from the service conductors. This can be accomplished in several ways. Firstly, the feeder conductors could be routed directly from the service disconnects to the remote panel boards without passing through the auxiliary gutter. This would require separate raceways or cables for the feeder conductors. Secondly, a separate auxiliary gutter could be installed for the feeder conductors. This gutter would be dedicated solely to the feeder conductors and would not contain any service conductors. Thirdly, the service disconnects could be relocated closer to the remote panel boards. This would shorten the length of the feeder conductors and may eliminate the need for an auxiliary gutter altogether. In addition to National Electrical Code Section 230.7, other sections of the National Electrical Code may also be relevant to this installation. For example, National Electrical Code Section 314.28 covers the requirements for conductor bending space at terminals and pull boxes. This section specifies the minimum amount of space required for conductors to be bent and terminated in enclosures. The auxiliary gutter must provide sufficient bending space for the conductors entering and exiting the gutter. Also, National Electrical Code Section 376 covers the requirements for metal wireways and auxiliary gutters. This section specifies the construction requirements for wireways and gutters, including the types of materials that can be used and the methods for supporting the wireway or gutter. The auxiliary gutter must be installed in accordance with the requirements of Article 376. Moreover, National Electrical Code Section 408 covers the requirements for switchboards and panel boards. This section specifies the requirements for the construction, installation, and wiring of switchboards and panel boards. The service disconnects of remote panel boards must be installed in accordance with the requirements of Article 408. Furthermore, National Electrical Code Section 250 covers the requirements for grounding and bonding. This section specifies the requirements for grounding the electrical system and bonding the non-current carrying metal parts of the system. The auxiliary gutter, service disconnects, and remote panel boards must be properly grounded and bonded in accordance with the requirements of Article 250. When designing and installing electrical systems, it is crucial to consult the latest edition of the National Electrical Code and to follow all applicable requirements. Failure to comply with the National Electrical Code can result in unsafe installations, electrical shock hazards, and fire hazards. It's important to note that auxiliary gutters are intended for specific purposes, primarily to supplement wiring spaces at meter centers, distribution centers, switchgear, and similar points. Their function is to provide additional space for conductors, taps, and splices, not to serve as a general raceway system for feeders. Using an auxiliary gutter in the manner described in the question supplies its intended use and creates a hazardous condition. The correct approach involves using properly sized and installed raceways to route the feeder conductors from the service disconnects to the remote panel boards, ensuring compliance with all applicable National Electrical Code requirements. To ensure safe and compliant electrical installations, always consult with a qualified electrical contractor or engineer. They can assess the specific requirements of the installation and ensure that all work is performed in accordance with the National Electrical Code and local regulations. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. Understanding the proper application of auxiliary gutters is essential for electrical safety. Auxiliary gutters are metal enclosures used to supplement wiring spaces at switchgear, panel boards, and similar equipment. They provide additional space for conductors, taps, and splices. They are not intended to be used as raceways for running feeder conductors over long distances or as a substitute for proper wiring methods. The National Electrical Code contains specific requirements for the installation and use of auxiliary gutters. For instance, National Electrical Code Section 376.20 specifies the uses permitted for auxiliary gutters, while National Electrical Code Section 376.21 specifies the uses not permitted. It is important to understand these requirements to ensure that auxiliary gutters are used safely and in compliance with the National Electrical Code. Additionally, auxiliary gutters must be properly supported and grounded. National Electrical Code Section 376.30 specifies the support requirements for auxiliary gutters, while National Electrical Code Section 250 covers the grounding requirements. Proper support and grounding are essential for ensuring the mechanical integrity and electrical safety of the installation. The size of the auxiliary gutter must be sufficient to accommodate the conductors and splices installed within it. National Electrical Code Section 376.22 specifies the conductor fill requirements for auxiliary gutters. The sum of the cross-sectional areas of all conductors in the gutter must not exceed 20% of the interior cross-sectional area of the gutter. This requirement is intended to prevent overcrowding of the conductors and to ensure that there is sufficient space for heat dissipation. In addition to the conductor fill requirements, the auxiliary gutter must also provide sufficient bending space for the conductors entering and exiting the gutter. National Electrical Code Section 314.28 specifies the conductor bending space requirements for enclosures. The bending space must be sufficient to allow the conductors to be bent without damaging the insulation or stressing the conductor terminations. The covers of auxiliary gutters must be securely fastened to the gutter body. National Electrical Code Section 376.70 specifies the cover requirements for auxiliary gutters. The covers must be designed to prevent accidental contact with energized conductors and to protect the conductors from physical damage. Auxiliary gutters must be installed in a neat and workmanlike manner. National Electrical Code Section 110.12 specifies the general requirements for electrical installations. The installation must be free from hazards and must be performed in a manner that ensures the safety of persons and property. When installing auxiliary gutters, it is important to follow all applicable National Electrical Code requirements and to consult with a qualified electrical contractor or engineer if you have any questions. Correctly installed auxiliary gutters can provide a safe and reliable means of supplementing wiring spaces in electrical installations. However, improperly installed auxiliary gutters can create electrical hazards and violate the National Electrical Code. Therefore, It is important to take the time to understand the National Electrical Code requirements and to follow best practices when installing auxiliary gutters. The prohibition against mixing service and feeder conductors in the same raceway or enclosure is a fundamental safety principle in electrical installations. Service conductors are typically ungrounded and carry the full available fault current from the utility. Feeder conductors, on the other hand, are protected by overcurrent devices and have a lower fault current capacity. Mixing these conductors in the same enclosure can create a hazardous situation if a fault occurs on a service conductor. The high fault current can damage the insulation of the feeder conductors, potentially causing a short circuit or ground fault. Furthermore, the mixing of service and feeder conductors can make it difficult to identify and isolate faults. During maintenance or troubleshooting, it may be difficult to determine which conductors are service conductors and which are feeder conductors. This can lead to incorrect procedures and increased risk of electrical shock. To prevent these hazards, the National Electrical Code requires that service conductors be kept separate from feeder conductors. This requirement applies to raceways, enclosures, and other wiring methods. By keeping service conductors separate from feeder conductors, the risk of electrical shock and fire is reduced. In the scenario described in the question, the feeder conductors from the service disconnects are routed back into the auxiliary gutter, which also contains the service lateral conductors. This is a clear violation of the National Electrical Code requirement to keep service and feeder conductors separate. The auxiliary gutter is acting as an extension of the service conductors, and the feeder conductors are intermingled with the service conductors within the gutter. This configuration creates a hazardous situation and violates the National Electrical Code. To correct this violation, the feeder conductors must be routed separately from the service conductors. This can be accomplished by installing a separate raceway or cable for the feeder conductors. The feeder conductors should be run directly from the service disconnects to the remote panel boards without passing through the auxiliary gutter. Alternatively, a separate auxiliary gutter could be installed for the feeder conductors. This gutter would be dedicated solely to the feeder conductors and would not contain any service conductors. In either case, the feeder conductors must be kept separate from the service conductors to comply with the National Electrical Code. It is important to note that the National Electrical Code is a minimum safety standard. Electrical installations should always be designed and installed in a manner that exceeds the minimum requirements of the National Electrical Code. This may involve using larger conductors, installing additional overcurrent protection, or providing additional separation between service and feeder conductors. The goal is to create an electrical system that is as safe and reliable as possible. Always consult with a qualified electrical contractor or engineer when designing and installing electrical systems. They can assess the specific requirements of the installation and ensure that all work is performed in accordance with the National Electrical Code and local regulations. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. The National Electrical Code is a comprehensive set of rules and regulations that govern the safe installation of electrical systems. It is updated every 3 years to reflect changes in technology and best practices. The National Electrical Code is not law, but it is widely adopted by state and local jurisdictions. In many areas, it is illegal to install electrical systems that do not comply with the National Electrical Code. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It also includes specific requirements for different types of electrical equipment, such as panel boards, switchboards, and transformers. The National Electrical Code is intended to protect people and property from electrical hazards. By following the National Electrical Code, electrical contractors and engineers can ensure that electrical systems are installed safely and reliably. The National Electrical Code is a complex document, and it can be difficult to understand all of the requirements. However, it is essential for anyone who works with electrical systems to have a thorough understanding of the National Electrical Code. There are many resources available to help people learn about the National Electrical Code. These resources include textbooks, training courses, and online forums. The National Fire Protection Association, which publishes the National Electrical Code, also provides a variety of educational materials. By taking the time to learn about the National Electrical Code, you can help to ensure that electrical systems are installed safely and reliably. Electrical safety is a serious matter. Electrical hazards can cause serious injuries or even death. It is important to take precautions to avoid electrical hazards. Never work on electrical equipment unless you are qualified to do so. Always turn off the power before working on electrical equipment. Use insulated tools when working on electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not sure how to do something safely, ask for help. By following these simple precautions, you can help to prevent electrical injuries and fatalities. The service equipment is typically the main control and protection point for an electrical system. Service equipment typically includes a service disconnect switch, overcurrent protection devices, and grounding electrodes. The service equipment must be properly sized and installed to ensure the safety and reliability of the electrical system. The service disconnect switch is used to disconnect the electrical system from the utility power supply. The service disconnect switch must be readily accessible and capable of disconnecting all ungrounded conductors. The overcurrent protection devices, such as circuit breakers or fuses, are used to protect the electrical system from overloads and short circuits. The overcurrent protection devices must be sized to protect the conductors and equipment they serve. The grounding electrodes are used to connect the electrical system to the earth. The grounding electrodes must be installed in accordance with the National Electrical Code to ensure that the electrical system is properly grounded. The service equipment must be installed in a location that is protected from physical damage and environmental conditions. The service equipment must also be readily accessible for maintenance and inspection. The service equipment must be properly labeled to identify its function and the circuits it serves. The service equipment is a critical component of an electrical system. Proper installation and maintenance of the service equipment is essential for ensuring the safety and reliability of the electrical system. Again, consult with a qualified electrical contractor or engineer.